A solution is a homogeneous mixture of solutes in a solvent. The solvent, which is the primary component, is typically water. And when it is water, we call this an aqueous solution. The solutes are the minor constituents, and these are dissolved in the solvent. We can talk about the concentrations of the solutes in a number of different units. The most common is molarity, which is moles of solute over liters of solution. It can be signified as either an italicized capital M or an underlined capital M, or just as moles per liter. An example of a solution is seawater. Seawater has 0.6 molar NaCl. That means every liter of seawater contains 0.6 moles of NaCl. If we have 2 liters of seawater, that means we have twice as much of the NaCl, and therefore we'd have 1.2 moles NaCl. How do we determine molarity? Let's look at an example. Let's say we have 3.28 grams of magnesium chloride, and we dissolve that in a 250 ml solution. We want to know the molarity of the magnesium chloride. So we need to figure out the moles of the solute, that's the magnesium chloride, and the liters of the solution. Let's focus first on the magnesium chloride. Magnesium is over here in the second column. Chloride is on the right-hand side of the periodic table. Based on where they are in the periodic table, we have something over on the left and something on the right. That means we're likely to form an ionic compound. The magnesium will be 2+. The chlorine will be Cl-. These are based on the groups they're in the periodic table. And so if we want to know what compound they're going to form MgCl2. This is our magnesium chloride. Next, we need to figure out the molar mass of the magnesium chloride. So we can go ahead and we can take 24.31, which is for the magnesium, plus 2 times 35.45, that's for the chloride, and we're going to get 95.21 grams per mole. We can use this to convert from our mass of magnesium chloride to our moles of magnesium chloride. So we go ahead and we take the 3.28 grams, we divide by 95.21 grams for every 1 mole, and this is going to get us the moles of our magnesium chloride, 0.03445 moles. That will be the top of our molarity calculation. We still need to figure out the liters, and so what we can do for that is we have 250 mLs. Well, every 1 liter is 1,000 mLs. So 250 mLs, we divide by 1,000 and we get 0.25 liters. Next, we go ahead and we take our moles and we divide by our liters, and that it will give us our molarity. So 0.03445 moles over 0.25 liters, and that's going to give us 0.14 moles per liter, or molar.